Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are breaking down one of the most important vector operations in physics and engineering, the cross product. The cross product, okay? So the cross product of two vectors A and B is written as A cross B, okay? This is denoted by A cross B, and it gives a vector that is perpendicular to both A and B, okay? When we find A cross B, we will get one more vector that is perpendicular to both vector A and vector B. So what is a cross product? Let's see, okay, a proper definition or something. So the cross product of two vectors is an operation that gives you a third vector which is perpendicular to both of the original vectors, and it is denoted by A cross B. But as we had it in the dot product, there it we got the scalar value, right? So dot product, which gives you a scalar, the cross product gives you a vector. Dot product gives you a scalar, but the cross product gives you a vector. Okay, let's see. Um let's say we have let's say we have two vectors, okay? Two vectors. Vector A equals to A1I plus A2J plus A3K, and B B1I plus B2J plus B3K. Okay, the cross product is calculated. Cross product is calculated using the determinant okay, determinant of 3 cross 3 matrix. Okay, I'll show you how. So I'll use different color pen. A cross B equals to I, J and K. Okay, I, J and K, this is the determinant, right? I, J and K, A1, A2, A3, B1, B2, B3. So when you expand this determinant, you get what? You get A cross B equals to A2, leave this. If you're like this two minus this two, product of this two minus this two, right? So A2 B3 minus A3 B2, okay, I minus now J. So J, leave that column, leave that row. A1 B3 minus A3 B1 J plus now this A1 B2 minus A2 B1 K, right? Now this gives us a new vector that is orthogonal to both A and B. So let me write this. This gives you a new vector that is orthogonal to both A and B. Done. Now let us see some key properties, okay? Some key properties of cross product. First one, A cross B is equals to minus B cross A. In the dot product, it was commutative, right? In the cross product, it is anti-commutative. Now, A cross A equals to 0. Here, a vector crossed, right, with itself is 0, and a cross b, these are the key properties you have to remember, equals to 0 if this is, if, okay, this is 0, then a and b are parallel. Okay, now if theta is the angle between vectors a and b, then magnitude of the cross product is a cross b equals to mod a mod b sine theta. Done? Mod a mod b sine theta. So this tells you the area of a parallelogram. This is going to tell you the area of parallelogram formed by the vectors a and b. So not only does the cross product give you direction, it also gives you the area. Done? Now direction I'll tell you. Remember this, I will write it. Direction, magnitude I mentioned, direction. That is the right hand rule. Something is right hand rule. So to find the direction of a cross b, this is a new the vector, right? This forms a new vector. So to find the direction of a cross b, use the right hand rule. So point your fingers in the direction of a, okay? Curl them towards b. So your thumb is the direction of a cross b. I'll tell you how. So if you can see, I hope this is clear. I'll just zoom in. Okay. So consider this is the direction A, this is the B, and this is perpendicular to AB. This is the new vector formed. Okay. I hope it is clear. Or okay, fine, we can show it in whichever hand we want. This is perpendicular A cross B, and this is perpendicular to both A and B. All right, now we will move forward. Then we have like the result is always perpendicular to the plane formed by A and B. And that's the cross product in a nutshell. A powerful tool in physics, engineering, and computer graphics. So if you found this helpful, hit like, subscribe, and let us know in the comments what topic you want next. Thank you for watching and see you in the next one.